These are two very difficult questions from gravitational fields, and the multiple choice questions in general in year 2 physics get quite difficult. So it tells you the distance between these two lines of equal potential are 20 meters. It tells you an object of mass 4 kg is moved from point P to Q. Okay, it's asked for the work done against gravity to move the object. Well, in gravitational fields, we know that work done can be given by mass multiplied by change in potential. That's an equation in your equation sheet. So if we multiply 4 by the change in potential, we'll be able to find the work done. You have to be a little careful here because moving from this surface to this surface, the change in potential is between V and V plus 3. So it's just 3 joules per kilogram. But is that the same as the change in potential between P and Q? It's actually not, because Q is only a certain section of the 20 meter distance. In fact, we only consider the vertical distance because the 20 meters that we took is strictly vertical. So we say that Q is 12/20ths along the way between V and V plus 3. So it will have 12/20ths of the change in potential, if that makes sense. 12 times 3 is 36. 36 over 20 is equal to 1.8. So we actually multiply mass by 1.8 because that is the change in potential from P to Q, especially in the vertical direction. 4 times 1.8 is then equal to 7.2 joules. So the correct answer here is option A. Moving on to this other question, I think this is even more difficult. So it says Charon is a moon of Pluto and it has a mass a ninth of Pluto. So we can say that if Pluto has a mass of 9m, then the mass of Charon would be just capital M. It says X is at the point where the resultant gravitational field is 0. Now that could mean gravitational field strength, gravitational field potential, but just for this question we'll use gravitational field strength. And because we're dealing with planets here, we know that it's a radial field, so we're going to use the fact that the gravitational field strength is gm over r squared. So it's asked us to find the distance of X at which point the resultant gravitational field is 0. So this Pluto produces a gravitational field with equal strength to that produced by Charon. Let's think about this a little bit. So if the mass is 9 times as large in Pluto and the gravitational constant is constant, in order for this gravitational field strength to be constant so that the resultant is 0, the square of the radius has to be 9 times as large so that the 9 and the 9 can cancel out, giving you gm over r squared again. In order for the square of the radius to be 9 times as large, the radius itself has to be 3 times as large, because if you square both sides from here, 3 squared is 9 and r squared is just r squared. So let's have a little think about this. That means that because this has 9 times more mass, particle X has to be 3 times as further away from it than it is from Charon in order for the resultant field to be 0. So we can split this up into parts. We can say that from Pluto to this point X is 3 parts, and so that's a ratio of 1, and from here to Charon is a ratio of 1. So we split D up into 4 parts, so that's D over 4, etc., etc. And we say one of those quarter parts of D is the distance from Charon to X, and 3D over 4 is the distance from Pluto to X. That way they also add up to D, and also the distance of X from Pluto is 3 times as large as the distance of X from Charon. So it's 3/4 D, which is option C. Quite difficult questions. You might need to go back and rewatch it, but yeah, hopefully that made sense.